is because we have these things in geometry theorems. Okay, the Pythagorean theorem didn't actually prove it. A theorem is something that we know is true because we can prove it to be true. We're building up a story, or we're true things, I guess, is kind of a way of doing it. So we start with the postulates. Okay, they're these things that we don't know where they come from, but we just we know that they're true. And then by using these postulates, these known things that we now assume are facts, and use them, we can put them together and prove theorems. And then we can take those theorems and use them, put them together to prove. It keeps going and keeps going and keeps going, and by the time you're done, you have everything there is in geometry. We have all this big set of theorems, all these relationships are true because we've been able to prove them. You go down to the bottom, there isn't anything left to use to prove stuff with. So we have there are these things that are like, okay, things are true, and are, then okay. With the figures, there are certain things when you guys were doing that exercise today, there are certain things that you could assume to be true and certain things that you weren't. You couldn't. We had no proof of each one of them. We were just able to kind of logically explain it, why it makes sense. But the two points exist exactly on the line. Does that make sense? I can't put a second different line through the same 2 points because I would be drawing right over the first one, and that's the same line. That's all that one says. Points. Does that make sense? It's going to do, otherwise I wouldn't be able to draw. It could be all sorts of just one. If two lines, does that make sense? 2 lines have to cross at a point. That's what that says. 4. Through any 3 linear points, there exists exactly one plane. We've talked about that, right? Every plane wouldn't be able to. Okay. Just look. Line plane, then the line containing them also lies in the plane. Does that make sense? If you've got a plane and 2 points that are sitting on it, and you draw a line that connects it in that plane. Okay? We can't prove that, but it's true. We know that's true. Also something we've talked about before, just didn't give it a name. If 2 intersect a line. We talked about that in chapter 1, right? If we have 2 planes cross, then where those 2 planes cross each other is going to form a line. Okay. with sort of diagrams and such here, so you can reference it real quick. But which of those postulates is this an example of in this sentence here? Let's have somebody else. Right? There. Not actually. Yep. It's the plane. Yeah. That is the points, right? My hypothesis is the plane. I'm starting with the plane. I'm saying if you have a plane, then you got 3 points in it, right? Instead of saying if you have 3 points, then you have a plane that goes around them. So it's kind of a, I know, a little bit of a small detail there, but yep.
So if you wrote it with the plane, with the points first,
Mm-hmm.
and you plane second, would that be 3-point postulate?
The 3-point postulate, 3 points, same as this. Points that are in there together. But then, yeah, it would. Can someone give me an example? Yes. Set it there. So word that with this particular one. Yeah.
Point C and D are on
We're going to spend the rest of our time for, and make it labeled enough that it shows this. We need to draw so that it intersects in that picture should look like. And then if we're getting enough stuff down. Thank you. You DF. So you should D is the beginning. Okay. So angle. Picture looks like a right angle. Got to have that. So, are we all good with that? Did that? Okay. Midpoint M. While you're working, quick question. Plane. Is it the midpoint of the segment or the midpoint of the plane? Segment, because planes don't have midpoints. Okay. You have to label it so it's the midpoint. If you don't know how to do that, just wait a minute and I'll show you. Okay. Where it's not out, it's not, it doesn't matter. Shh. So, plane first, but it doesn't mean you have an S with an S in the corner, right? Point M. It's in the middle, and that's it. We have to label it such that we know it's the midpoint, and what that means is putting those little slashes through those two sides congruent to each other. Okay? Now, that's okay. So, point, so it's really looks bad. I don't care. I label them I labeled those two segments congruent. They're congruent. So be careful. Come days in the future when you're working on some problems and you're trying to make a proof or you set up an equation or something, and the answer is drawn intentionally incorrect. Correct. You have to follow how it's labeled, not okay? FD. Go. Try it. We don't know how much further we have to go unless you try and see how far you can get first. So try it. Just try. That's a good. We know there's going to be a plane. And we'll fill in the gaps later if you need some help. Did you put a line segment in it, AB?
Just put plain G.
You can start putting some of that other stuff in there too. We're running out. Let's just do this, okay? Yes, good place to start. Label it correctly, doesn't matter how bad it looks. Okay? Plane. It's like, think about this pencil poking through this piece of paper. It just comes down through it. Plane. You can do this. I'm doing this. Just take a step at a time. Start together.